We're in Rosen 9.4 on solving congruences. This is an application of the Chinese remainder theorem to a system of congruences. X is congruent to 1, mod 5. X is congruent to 2, mod 6. And X is congruent to 3, mod 7. And using the construction technique, first we form little m, which is the product of the relatively prime moduli, which gives us 210. And then we form the capital M sub i's. M1 will be 210 divided by 5, which is 42. M2 will be 210 divided by 6, which is 35. And M3 is 210 divided by 7, which is 30. And now recall that we find the inverses of the capital M's with respect to their individual moduli. So I form M1 Y1 is, it's going to be congruent to 42 Y1. That needs to be congruent to 1 mod 5. But remember, I can take the modulus of any factor, any term, and retain the modulus. So that's going to be congruent to 2 y1, and that means y1 can be 3. So 3 is an inverse of 42 mod 5. Let's do the next one. M2 y2 is congruent to 35 y2, and that needs to be 1 under mod 6. I'll take the modulus with respect to 6 of 35 to get 5. Oops, y2, sorry. And that means that y2 equals 5 is an inverse, because 5 times 5 is 25, divided by 6 has remainder 1. All right, let's do M3, congruent to 30 y3, and that needs to be 1 under mod 7. And I will take the mod with respect to 7 of 30 to get 2. And that means that y3 equals 4 is an inverse of 30 mod 7. And now I form my solution. X is going to be equal to 1 times 42 times 3 plus 2, the value that it's equal to under mod 6 times, 35 times 5 plus 3 times 30 times 4. And that's actually a congruence under the modulus of 210, and that is congruent to 836, but that is congruent to 206 if I take the remainder of 836 with respect to the modulus 210. And if you divide 206 by 5, 6, and 7, you'll get 1, 2, and 3, respectively.